Good days to everyone. Today I want to present for our industrial visit project. We have visit to FGV Plum Industrial Sdn Berhad on 11 June 2026. We are from Group 7 and the member is me, Qin Jin Sun, and our teammate Ethan Zhong Zheng Yu, Sun Wei Song, and Wen Jiaguan.
Good day, Doctor. I'm Ethan. Now I will be starting for the presentation by talking about the introduction first. The location that we went for the industrial visit is at the KKS Felda Maukil, and the date that we went there is 11th of June 2026. And the person in charge who are required to bring us around the facility is first Mr. Musidin, which is the man standing at the middle of the picture, and also Mr. Hussein, which is the person who is taking the photo for us. And our tentative that day is that we are required to arrive at the facility by 8 a.m. in the morning. So after we arrive, we take the visitor pass from the guardhouse and we enter the facility. And they are providing us with a breakfast. So we had breakfast first, and then after the breakfast, we went for a safety briefing, which they talk about the emergency gathering points and also the hazards from the methane. And we are required to wear a safety helmet for the whole trip. So after the safety briefing, the person in charge bring us around the facility to look into the machines that are operating inside the facility. So after the trip is done, they provide us with lunch, and after lunch, we have a photo taking session, and then we just go back to our university. And this is the picture that we take with Mr. Hussein, which is the man standing in the middle of the picture. So we really appreciate their patience for explaining everything in the facility and also bring us around. That requires a lot of time and energy. Now for the company background. The facility at the KKS Felda Maukil is owned by the FGV company. So it is a government linked company, which is a GLC, that is founded in Malaysia in the year of 2007. The FGV company produces is one of the largest producer of crude palm oil in the world, which they supply 3% of the whole global market, and for Malaysia is 14%, which is the largest supplier of crude palm oil in Malaysia. FGV company have a lot of facilities around the world. So for example, they have some trading facilities in the USA, Spain, France, and they have some oil refinement facility in Pakistan, and some rubber refinement facility in Thailand, and so on. They are the FGV company is an agri-business company. So what they utilize is the agriculture crop, for example, palm, the palm fruits and other plantations. So in the KKS Felda Maukil, they are producing the crude palm oil, which is not refined yet, and they utilize the byproducts of the palm, the palm plant to produce biogas to generate electricity to sell to TNB and generate a revenue. So at the left side of the picture here is the Wisma FGV, which is the headquarters of the FGV company. It is located at Kuala Lumpur. So at the right side here, we can see these are the some of the products that are produced and supplied to the market from FGV lah. The most popular product here, I guess, is the Saji cooking oil. and also the sugars, for example, the white sugars and also the brown sugars. These are the main products that are produced by the FGV from their agriculture activities. So now we will move on to the most important part, which is the machines that they use in the facility. So the first machine that we observe is the biogas generator. So FGV uses the byproducts of the palm plant to produce biogas. So they supply the biogas inside the generator, and the ratings of the generator is 600 kilowatt per generator, and they have two of them. So one of them is made in Germany, and another one is made in Spain. So the potential that they can generate is 1.2 megawatt of electricity, and the electricity that they produce are sold to TNB to generate income. So the second machine that we observe in the KKS Radamaku is the air circuit breaker, which is ACB. So the purpose of this circuit breaker is to protect the system, and it protect the system from fire because maybe there is a fault in the system that can cause a high heat. So this ACB will break the circuit and prevent the fire from starting. It also prevent excess current from entering the system, and also it have a short earth protection. So the standard rating for the ACB is around 3,200 to 4,000 ampere. So any current above that range will cause the A circuit breaker to function. It will break the circuit, so the damage to the system is not very big.
Good day to doctor. I'm Sun. So I will continue for the machine 3 transformer. As we know that the biogas generator produces electricity at 450 watts, but to sell this power to TNB and feed it into the national grid, we need a much higher voltage, which is 11 kilowatt. So the first job of this transformer is set up. It boosts 450 watt to 11 kilowatt. This reduces the current, and which can cut down the power loss during the transmission to the TNB connection point. However, the plant itself also needs electricity to run. So the transformer also performs a second job, which is step down. It takes the 11 kilowatt and step it back down to a 7 lower voltage for factory use. The label DYN11 simply tells us the winding configuration and phase shift. It's the standard Malaysian grid setup that ensures the stable operation. Okay, so let's continue for the machine 4, which is PV inverter. So its main job is simple. The solar panel generates DC power, but the grid runs on AC. So the machine converts DC into AC. Once converted, this AC power flows to the transformer where it gets stepped up to 11 kilowatt and sold to TNB. So let's take a look for the specs. It has a maximum output of 110 kilowatts on a brightly sunny day. It also has IP66 protection, which means it's fully dust tight and can handle heavy rain, and it is perfect for the Malaysians outdoor weather.
Despite this robust system, we noticed some significant operational issues. First, generator pistons frequently suffer physical damage, causing costly downtime of 3 to 5 days. Second, the PLCs are prone to failing due to overheating in the harsh factory environment. Third, the continuous heavy loading on the transformers accelerates the degradation of the internal insulation oil. And lastly,
The Solis PV inverter operates in a hot tropical climate, pushing it dangerously close to its 60 degrees Celsius maximum operating temperature. So, to improve reliability, we propose the following. First, maintain an on-site inventory of large foreign spare parts to drastically cut the 3 to 5 day generator downtime. Second, install dedicated active thermal cooling system for the PLC panels. Third, implement biannual dissolved gas analysis testing for the transformers to monitor oil health. And lastly, construct an overhead shading canopy for the PV inverters to block direct sunlight.
For discussion, we found that the financial and energy output for the whole process are highly impressive. For example, the plant are able to generate roughly 22,000 kW per day and a totaling of roughly 650,000 kW per month. By selling this energy at approximate of 30 cents per kW, the plant's able to get an annual revenue target of 3 million ringgit. In conclusion, this industrial visit project gives us a chance to observing the electrical machine on how they work together and provide an excellent insight in real-world application. It also shows us how engineering can turn palm oil waste into a highly profitable and sustainable energy ecosystem. That's all for our presentation. Thank you.